Hello, welcome to Alt Mouse Labs. My name is Penny. I'm glad you're here. Today we're going to be talking about the PIXELFALLS game engine again, and this is going to be a slightly more advanced one. We're going to be looking at animation and interaction a little bit. Let's get started. Alright, I'm here in preview.pixelfalls.co.uk, remembering that this is a kind of pre-alpha. If you want to join in and be able to kind of play with the engine, you do need to join the Patreon. It will be linked below. I'm going to start by hitting F11 on my keyboard, which is going to take us into full screen mode. The next thing I'm going to do is I would load my game, which I already have. It's by our Learn PIXELFALLS, and I have added a picture to the cart. You can add a picture to the cart by holding Control-Shift-C while the game is running, and it'll capture that, or you can do it manually. Okay, so let's start with a quick playtest, just show you real fast what we're doing. Alright, so this is just like we had before, with a couple of differences. We have our collision, but we now have animated walking. You'll notice we turn, we go left and right, we walk, we go up, and we go down, and in all cases we're fully animated and walking. The other thing we've changed is if we go talk to our cat now, he will tell us that he loves us, essentially, and then that will go away after 1 minute. So let's go ahead and see how to do all that. First of all, I'll go to your sprite editor, make sure you have sprites. You can put these wherever you want. Make this a little bigger. So I have a sort of standing, a raised leg, and another raised leg, and I have that same basic pattern: standing, raised leg, standing, raised leg. I only have going to the right because I use flipping to go to the left. You could technically have a different left picture if you wanted. Okay, so we need our pictures, we also need our cat, and we need our heart. Going to our code editor now. Our code has changed a lot, so I'm going to go through it step by step. First of all, I have added a cat prop. A reminder that a prop is essentially a class without a code file. It is an object, I guess it's a game object, that can be put on the map, it can be moved, it can be given a collision, it can be given tags, but you cannot code directly into that object. A node is a full class with its own code sheet. So we added the cat as a prop and the heart as a node. For our cat, we set up the picture, which again, you just click on the picture section and set that up. We would just set up our cat. Then we go into settings. We are going to set its collision to cat. We're going to give it a collision box. Remember the tags are how we are currently referencing things for collision and in now interaction as well. We're going to enable collisions. That's it. For our heart, we did the same process as far as setting up collisions and the picture. And then in the code sheet, we set up our lifecycle methods of init, update, and actually we didn't include draw because we're drawing from the map, which I'll show you. In init, self, which is a reference to the class, x and y are coordinates on the map. Self.x equals x means the x for the instance is the x assigned. The y for the instance is the y assigned. Self.lifetimer is a timer that we're creating. Under update, we increase the lifetimer by 1. The game is trying to hit 60 frames per second. Now, this is going to vary depending on how many collision checks you have, how complicated your game is, and the computer that's running it. But it's shooting for 60 frames per second, which would mean 60 frames is 1 second. And we say, if our lifetimer is greater than or equal to 60, then destroy the heart. So that's how we're getting the effect of it appears and then it disappears. We're just creating it, it lasts a second, and then it destroys itself. Okay, next up, in player, let's finish with the heart first and then we'll come back to animation. So, we've created a function called interact, which takes an object, and it says if has collided the object and anything with the tag cat, then spawn one of our hearts at position 8,8. Now, you could set it up so that your heart spawns wherever you tell it to. So you could have a function interact and then say like x pose, like you could do, let's see, like x position, can't type, sorry, x position, y position. And then you could then put the x post and y post right here and set where the heart appears. Just for the sake of it, we'll just do that real fast. We'll set it to x post, just so you can see how it works. Y pose, and then where we actually make the heart, which is down here in our in our update, we're saying check for interaction every frame, and this time we're going to say if interact happens, let's go ahead and make the heart appear at 1616. So we've added 1616, which goes up to our interact, so it's now the object, which is the player, the position of 16, the Y position of 16, that's where it's going to spawn. If we hit play and we go talk to our cat, the heart is now appearing where we told it. So you can make it more flexible, but since I know for this little game I always want it to appear at 8:8, I'm going to go ahead and put it back the way it was. So it's just taking in the player and setting the cat or the heart to appear hard-coded at 8:8. You may have noticed spaces are optional. I like to add in the spaces because it looks better. It's easier to read. Sometimes I don't while I'm testing, but I'll go back and fix it before I leave a coding session. All right, so now we got it back to 8:8. We're going to go ahead and make sure, boom, back to how it was. Wonderful. And that's it for the heart. You created interaction, and now we did the heart. It's very simple. You could also do something like create dialogue, and then when you bump into something with the, say, interact tag, it could create a dialog box and put whatever sentence you put on top, you put in as a string. Maybe that's what we'll do in the next one or in an upcoming tutorial. But for now, I just wanted to show how you could get basic interaction. So that's it for our heart and our interaction. Okay, now for animation, it's a little bit more advanced. All right, so the first thing we want to do is if we're going to have interaction, if we're going to have animation, it's going to be impacted by our controls. So I created a function called move, takes in self, which is a reference to the object, and it uses the same move code we set up earlier for our collision. So if button down, key right, then self.x plus equals self speed, self.flip equals false, meaning it's going to the right, it's not flipping the sprite. Check collision self, animate self 1. We had that same basic pattern for all 4 directions. So check collision. I did want to let you know, I got a correction from the last video. So the lead developer, Chris, let me know that the reason this works is not because it's moving so fast that you can't see it popping back into position, but rather that it does the entire code process before flipping to the next update frame. So it goes through that whole process and then runs it. So basically the computer comes to the right conclusion before it shows you the frame in draw. So I was wrong about that. It does work the same as far as you don't see any movement, but it's because no movement actually occurs. So there you go. Pretty cool. But anyway, so we check our collision. We don't move just like before. That's the same. Then we check our animation. Our animation is its own function. It takes in an object and something called an anim. And the anim is which animation. Is it walking down, walking to the side, or walking up in this case? We say object.anim equals anim. So if we go down to our object, our init, we have self.anim equals 1. So when we run animate, it changes that self.anim to whatever we set it to. And then it starts up our animation timer, object animate timer plus equal 1. Our animate timer is defined here in init as well. As self.animate timer, it's 0 to start. So it starts going up. If the timer is greater than or equal to 12, then the object.current frame rate goes up by 1, or current frame goes up by 1. Why 12? 12 is roughly 5 frames per second. You could also put like a number divided by 60 there. Well, you couldn't do it that way with the way we've set it up. So you have to kind of play with it until the way we've done it, until it looks good. And I found that about 5 frames per second, but that is to say 12 ticks, is about what looks good. We increase the current frame by 1. Current frame is established down here as well. Current frame is 1 by default, so we increase it by 1. And then we set the animate timer back to 0. So the whole thing is in a loop over and over again, looking for the animation, setting the animate timer up by 1. If it's 12, changing the current frame and going back to 0. Next, we say if our current frame is equal to object.frames anim plus 1, then the current frame equals 1. Well, what the heck does that mean? First of all, when you do a pound sign in front of a table, object.frames is a table, that says, give me the length of this table. So if the object.currentFrame is equal to the object.frames table length plus 1, then we go back to current frame equaling 1. Where is current frames? Current frames is established here in our init. Yeah, here we go. Self.frames, we have 1, 2, 3 tables inside of a table called frames. So this is the first animation, the second animation, the third animation. Our animate function loops through each of these numbers and then goes back to 1 and keeps going. Each of these numbers is a sprite. So for instance, we have sprite 1, sprite 17, and sprite 33. If we look in our code, 1, 17, and 33, we have 1 twice because it's standing, moving left, standing, moving right, the foot, and that's how you get the walking. Okay, next up, we'll go back up here. So hopefully this makes sense. I'm going to go through it top to bottom one more time to be clear. We created a function. It takes in a node, our player. It takes in an animation, which animation we want to play. Then it sets a timer going from 0 to 12. Every time it hits 12, the frame goes up by 1. Every time the frame goes up by 1, it checks to see if it's reached the end of the animation, and if it's, so for instance, the first animation, if it's currently 1, plus 1. So if there's 4 frames, it's going to look for 5 total. If the current frame equals 5, it goes back to 1. That's what gives us our smooth animation. Okay, hopefully that made sense. You can also just copy this code and play with it. So we have our animate set up. In our init, we have all of the various variables set up. We create our animations by making our individual sprites in the sprite editor and then setting them up in sequence, just like you would a flip animation. We have walking to the side, walking down, walking up, and we are good to go. Then in our move, we simply tell it animate self1. So this is animating if we're going to the side. This is animating if we're going to the side and it flips the sprite. This is animating if we're going down, and this is animating if we're going up. Finally, we have to draw it all. So in our draw, you draw sprite, self.frames, so our frames, our set of animations, which animation, so 1, 2, or 3 in this case, and which frame, 1, 2, 3, 4, for instance, for our first. So this is saying do each for the current frame of the current animation of all of our animations, all of which is set up in a round by our animate function. Then we're going to do self.x and self.y for the position, 1 and 1 for our width and height in this case. And self.flip will determine either yes, it's flipped or no, it's not. I know it's a little complicated. Hopefully that made sense. Please let me know in the comments if you want me to re-explain it. I will certainly try my best. But animation is just a little bit complicated. There's only you can only make it so easy. I will keep trying to refine this, but this is a great way to get started. And once again, with one function and a little bit of time, you end up with pretty smooth, pretty good animation because of the fabulous collision setup that we get from the PIXELFALLS engine. All of this is automatic. The Y sort for the trees is automatic. And as a bonus, we set up a little bit of basic interaction. So hopefully that was helpful. I guess the only other thing worth mentioning today is that the way you would do these animation frames, I keep it pretty simple. If you look here, we have a little guy who's raised up by 1 because that gives that sort of walking feel. And the rest of it's just flipped. I wanted to mention one other thing, and that is this nifty feature within the engine. If you take a look at play, down here it says show collider. If you hit this, you can actually see your colliders in real time. So that's just a little extra feature that is really helpful for development. All right. Thank you so much. Please consider liking and subscribe. Please consider joining the Patreon and supporting Chris, supporting Pixel Falls, and happy game making.